Hello, everyone. Good morning.
Yeah, good morning, sir.
So, thanks for joining. And okay, so today I think we are going to see about this full stack and big data based developments and integration stuff with Docker kind of things. So before I do get started, this is too early that people have to. Some people may have not got the join links in their inboxes, so they have to um, join properly. And some people seriously do not know how to join, and so there are so many difficulties. Okay, so so first part, I'm going to start with a basic introduction about SloopStash and what we are going to do in this session and how we are going to make this thing work. Okay, so I think I have shared this. Um, um, I mean, if you see the notes of the meeting, so I will do my screen sharing. Uh, I think where am I? Fine. So I think I will do my screen sharing. Okay, so I have an agenda prepared today. I just need a couple of hours of your time. Okay, because it will be fruitful to you as well as for us. Okay, I just need 2 hours of your time to produce some fruit out of this workshop. Okay, so if you see this, this is the meeting agenda, or maybe you may call it as a keynotes. And I will start with a basic introduction about what we have been doing. And then I'll be touching one important topic specifically for people who are DevOps cloud aspirants. Okay. And then I will be getting onto a whiteboarding on how we can do a seamless full stack development with container tools. And then we will go on to data engineering related topics. So we will
We're not
move
able to see
slowly
your
from.
screen.
Okay, I'm sorry. I think I forgot to. Okay, I'm sorry for that. Is that my screen now visible to everyone? Everyone able to see? You guys can react. Okay, so let's make this an interactive one. So you see a react button here, and you can click here and you can share your emotions and all that. Even the chat is open. Okay, but I recommend people to wait patiently, and finally I will spend lots of time for chat. Session is only 2 hours. Okay, but after that we can discuss a lot. You can ask lots of questions. Maybe something could be foolish also. Okay, that I can entertain that as well. Okay. So the agenda is basically available in the meeting notes. You can see here the welcome note and how to become as a DevOps and full stack environments. And then we finally discuss about data engineering stuff. And then we discuss about multi-node data engineering related workloads to be run. So basically, this is going to be a topic which mostly focuses on DevOps and containerization tools and how that can be correlated with a full stack, how that can be correlated with the big data workloads. So that is what we are going to see today. Okay. So if when I'm speaking, if you guys have any questions, I would recommend you guys to note it down in a paper, and I will give definitely more than an hour of question and answer time once the session is over. Okay, so I can't make people wait for too long till afternoon. So I will take only 2 precious hours, and I will just put all things what I wanted to share and into the display. And then what you do is you can, whoever wants to ask so many things, you can stay, and we will have a discussion time after that. Okay. So this is my agenda. Okay. So let me start with the opening. Okay. So what is that introduction that we've planned? If you see here, usually I use this Obsidian's thing to do that. So I'm going to first do an introduction about what is SloopStash first of all. Okay, so SloopStash is basically a technology-based startup program. Okay, and not a startup program, startup company, and our most focuses in this technology world is that we are focusing more on the B2B SaaS and we are focused more on the open source software. And we build technology solutions and we are in the training as well. Okay, so basically SloopStash is a company which is dealing with a software as a service product. And in origin, it's a product-based startup. And then we aim at open source software as well. We have lots of open source contributions under the belt. And we also provide technology-based solutions to the companies. And we also are involved in training technologies like the DevOps, the cloud, and some parts of full stacks and data stuffs and all that. Okay, so that's the brief introduction about SloopStash. And I am John. Okay, so I think in the meeting, if you can check here, I have given all my LinkedIn details and all that. If you can see in this, when you are free, you can, I think there was a meeting link, right? Okay, so I will share that, my LinkedIn profile and all that, and you will be able to connect with me in LinkedIn. Okay, that's not very important as of now. Okay, so we have lots of things to cover. And so basically, what is the product that we are building is, we are building a product called the Sloop engine, and it's an R&D based product. And we've been building that to enable secure access auditing features along with developer IDEs and all that on the cloud. So basically, it's a browser-based stuff, okay? And you can access the app, and if you want to see that in action, you can see that here. So it is live now, running on the cloud. Okay, so this is our product. This is our account. Anyone can sign up and use this. Okay, and that's a B2B SaaS. And then what we have been doing in SloopStash is that we are also involved in some kind of a training programs, mostly DevOps, cloud, and related to big data technologies and all that. And that is our agenda about the training stuff. Okay. And then we've been involved in the GitHub open source related development. So we build lots of start kits too, and so that we can power up the developers. One of the important things that we've been doing in SloopStash is that we want to simplify the development burden of teams, whether it could be a big data engineering development program, or else if it is a full stack development, or else if it's things related to DevOps, or if it is related to cloud. So we wanted to simplify everything, and we wanted to, our open source projects aim at simplifying the software development for your team. Maybe you may be wondering how to go bring the new trending technologies like Docker, Kubernetes in display, or you wanted to learn some Ansible, you wanted to get started with the Terraform. But those places, people have always the nerves. They can't get into that immediately. But what we are trying at SloopStash is that through the open source, we are trying to give people that they can, their teams, they can get started immediately. And that is what we are going to see today. We are mostly going to concentrate on open source today. And my displays is going to be mostly on open source. Okay. And anyone can access that in the GitHub, okay? And I will make all things available to you. You can try it in your free time. And also, we have been involved in lots of VM engineering stuff. We've been providing the virtual machine platforms in a registry called Vagrant Cloud. And we offer lots of Linux operating systems. Some of them are mostly customized as well. Okay, and then we also are involved in container platform solutions. You can check out the Docker Hub. So we'll offer lots of full stack workloads and the big data workloads and container-based solutions, mostly revolving around the Docker and Kubernetes stuff. And this is what's the first simplistic explanation about what SloopStash is involved in. And Inceptez is our training partner. Okay, so Inceptez is our training partner. I hope some of you here maybe from the Inceptez data training program or something like that. So Inceptez is our comprehensive training partner. We have been associated with them for the last 5 years, and we have conducted numerous training programs on DevOps, cloud, and many other things like the full stack and programming and all that. So this is the brief introduction of what we are doing at SloopStash. Okay, so now I am not going to spend more time in introducing what we have been. Okay, so that's not the workshop is all about. Now I'm going to get into the topic. Okay, all I want is your attention and concentration for the next couple of hours, maybe not more than 1.5 hours, so that you can reap some benefit out of this. Okay, could be a game-changing thing for you if you are really concentrating. So just concentrate on the screen, note down your questions. We will discuss about that elaborately after some time. Okay, so I'm going to get into my keynotes. Okay, so the first thing which I'm going to talk about is that I'm going to talk about if you are a person having a question that what is DevOps? Okay, what is DevOps and what is the learning path? I mean, some of the people may be asking a question that these days there is a lot of openings for DevOps job market. It was not a very highly available thing 4 years back or 5 years back, but if you see now there is a lots of awareness about DevOps, and many companies are hiring DevOps related engineers, DevOps cloud based engineers. So it's a kind of an hot trending story now. Okay, and we have to know what it is all about. Okay, so what I'm going to talk in the first thing is I'm going to do a small whiteboarding on for the people who are really new to DevOps. I mean, you can be a DevOps engineer in an organization now sitting in the workshop, but what I wanted is that the people who are really do not have no idea on what is DevOps and what it is, how it is correlated with today's workshop and all that. I just want to give a kind of a path or a clarity on what we're going to deal with. Okay, so the first thing is I want concentration. You guys note the questions on a paper or something. I will explain that, okay, once the session is over. So I'm going to now talk about the topic called I'm new to DevOps. What's the best path for learning container technology? In this DevOps workshop, we're going to mostly deal with container technologies. If you see here, we're going to deal with the Docker stuff. We're going to deal with the Docker tools like Compose and all that, and how that we are going to correlate with the big data workloads, and how that we are going to correlate with the full stack environment. So how that is going to get correlated. So before doing all that, going to the technical stuff, we need to be more practical in understanding what it is all about. Okay, so if you are a newbie and you haven't learned anything about DevOps all through this, I just want your concentration for next 10 minutes, and I will complete that. Okay, so let's say I'm going to now open a new drawing. Okay, so please listen carefully. Okay, need your attention. Okay, so then only you can ask more questions after the session is over. Now, for a DevOps engineer, I'm talking on topic of I'm new to DevOps. What's my learning path? So the first thing, how we train people in the DevOps training programs and cloud training programs and many other things, is that we always start with the platforms. Okay, when you see here, the first thing that we want people to understand is the platforms. Okay, platforms means what is platforms? Okay, platforms. What is platform or platform? Okay, what is a platform? Now, a platform is something like I'm mostly focusing on when I say a word platform, I'm focusing on the operating systems. Okay, I'm mostly focusing on the operating system. So, what is the operating system is all about? When you go to DevOps engineering work life, basically, one of the most highest evaluated operating systems that you come across is the Linux operating system, because most of the technology that you've been using in the open source world today is inspired by the open source kernel. That's the Linux kernel. You get the point? Why we are mostly focusing on the program of platform engineering program? Because a DevOps engineer has to firstly have a lot of a solid understanding in the platforms engineering field. Okay, so what is the platform I'm going to talk about? Now I'm going to just be a bit literal. So I'm talking about Linux operating system. Okay, a Linux operating system. We have to have a good understanding about this one, really. There are different Linux operating systems. I'm not going to say that we're going to see that the Linux, every Linux you have to learn. Linux is just an operating system. There are different flavors of Linux operating system, meaning there are flavors like something like you have a CentOS Linux operating system. You have there is something called as an Alma Linux operating system. And then you have maybe you have another thing like the Amazon Linux operating system in Linux, and this is a CentOS Linux operating system. CentOS, Linux. And then we have another operating system. I mean, something like maybe Ubuntu is the famous one. Ubuntu Linux. So there are different Linuxes available. Okay, there are different Linuxes available. I'm not going to say that you have to master Linux. Okay, in order to have a good sweet career in DevOps, you don't need to master Linux. But what you need to know is you have to have good understanding about what is called a platform. Okay, very recently in our training programs, one of the training programs, I've been discussing to people about platform engineering stuff. Maybe something that is a very new thing that you haven't heard of. You haven't heard of a platform engineering stuff, but platform engineering is something which will come to a very into a very liveness in next 2 to 3 years. You will see lots of openings for platform engineering stuff, and it is all mostly going to focus on if you are saying that you are a DevOps engineer and that is one big chunk of your life. You understand the matter? So the one big chunk of a DevOps engineer's life is all about understanding the platforms in which you are operating. Okay, you are running the production, you are running the development, you are running so many things. And where in the world it is running? It is running on some platform. And that's what we're going to first learn. Okay, so this is what is my first take on this workshop. So if you are willing to become a DevOps engineer, the first take has to be the platforms. Okay, the first take has to be the platforms. And that's the best way that you can get started. Okay. So these are all the Linux types, and in generally what we tell people is that we touch all the flavors of Linux, and that's not too really hard, like how you think that Linux is too different and difficult. Okay, and there is a reason for talking about this, and I can't write all the reasonings. Okay, but because Linux is an open source kernel. And most of the container technology that you see, the Docker plus Kubernetes stuff, it's inspired by the Linux kernel, built for the Linux kernel. And that is one of the reasons why we go for platform engineering. And that's the first thing. Okay. So what's the DevOps engineer is going to do in the next level? Or if you are a cloud DevOps aspirant, I don't want to put cloud a separate part. DevOps, cloud, all is all something which is meddled and merged together. Okay. And if I wanted to start with the next thing, I wanted to say, for example, if you ask me, I just wanted to, let's say I would like to put a arrow, only for just arrowhead. And I wanted to put the next level of a DevOps engineer is like, that's wrong. It's like learning about some kind of a data structure and some kind of a programming. Okay, that is also very important. People believe that sometimes when I ask people why they come for DevOps engineering role or cloud engineer, they say that it's okay. I think we don't need to code anymore, so we can actually come to DevOps or some kind of a cloud or something like that. So we don't need to code anymore. People who are bored with programming, people who are bored with doing certain things, doing some stuff and all that, they actually believe that DevOps engineering is their destination. But to be a surprise that I wanted to say that it is not a cakewalk. Okay, so it's like we have to learn some parts of programming. We have to learn some parts of the data structure, because why I say that is when you talk about the infrastructure of automation tools like the Ansible, the Kubernetes, the Docker, the Terraform, everywhere you see lots of infrastructure as code comes, which is mostly an YAML-based data structures. You get the point? And that is one of the reasons why people come to DevOps engineering, because there is less programming, and that's not the right idea for approaching the DevOps engineering role. Okay, so that is the first thing I wanted to say. Okay, when you are approaching a DevOps engineering role, you have to make up your mind that it is going to have programming. Maybe it is not the centric part. Okay, it is not the centric part, but it is also important. Okay, so programming plus data structures. Okay, that's also going to play an important role in DevOps engineering work life, because whatever tool you take, for example, what I'm saying is the Terraform. If you go to Jenkins, if you go to Ansible, if you go to Docker, if you go to Kubernetes, everywhere you see data structures in play. Okay, and you need to have little Python programming or some Ruby programming stuff to add more flavor to a DevOps engineering work life. Okay, and what are all these things which I am talking about? I'm mostly talking about you may need to have some idea on YAML and JSON data structures. Okay, and you may need to have some kind of a Python or maybe a Ruby programming skill or a shell programming skill like that. So this is what literally I'm talking about. Okay, I'm not talking about the something which is not a very irrelevant thing. So I'm just talking about something which is more relevant to DevOps engineering work life. Okay, you have to have some idea on YAML or JSON or maybe a Python plus a Python or a plus a Ruby or a plus a shell. It would do your DevOps engineering work life more better. Okay, and then you can have a very prolonged career in that. Okay. And then what is the next thing that we are focusing on? What's the next part for a DevOps engineering work life? The next part is about understanding the workloads. Okay. When I say DevOps engineering is not about just in its own. It's all about the other things on the organization. We can't say that we are a DevOps engineer or a cloud aspirant or a cloud engineer just by focusing on our own roles, because we in it have no bigger things to do, but we work for the other teams, and that's the main motive of DevOps. Okay, and when you particularly come to DevOps engineering or cloud engineering roles, the third important understanding that you need to have is about the workloads. What is the workload now? Let's get into the workload. So I just take this to the down. Maybe I don't want to go too much right or left. Okay, so I just take this and I just put it like this. And so what is the workload now? This is the place where mostly the people get puzzled on what is a workload. It's a very simple English word, and it's very simple to understand that. It's not a very difficult or cumbersome word to understand. Okay, so what's a workload? It's nothing but a software service that you are trying to run in a platform. You get the meaning of it. It is nothing but a software service, or let's say, for example, give me more context for that. So what's the workload? Suppose if you're a full stack developer, okay, full stack developer, you can fairly say my workloads are like a full stack workloads. Okay, so what do I literally mean? So I just mean this thing. So I've just putting it here. So let's say, let's say you are a full stack engineer. Okay, you're a full stack guy, and you say, what's my workload? Okay, so I will explain that. And then if you say I'm a big data engineer or a data engineer, okay, I have few things to discuss. Okay, and then what is workload in my context? And then if you say that I'm a maybe I'm an AI machine learning developer, ML ops and all that, so I develop things like that. So how in the world this is going to fit for me? So what does that DevOps engineering is going to do in my work life, in day-to-day my work life, how that can be correlated? And that is what we're going to see. Supposing if you're saying that I'm a full stack engineer, what is the full stack engineering is all about? The full stack engineering is all about, maybe you're a, let's say you're a Python developer. So you know how to write some Python code. So you're a developer, maybe dealing with the Python code basis, or maybe you are a Node.js developer. Okay, you're a Node.js developer, or maybe you are trying to become a, maybe say your let's say Python plus MySQL plus something plus full stack means it's not just the code that you do, and Node.js plus MongoDB. It's all famous stacks. Okay, MongoDB plus so and so. Okay. So if you are a developer like this, okay, and what is this workload meaning to you? The workload is basically nothing but the software services. Your Python app is a software service. Your Node.js app is a software service. Your MongoDB is a software service. The MySQL is a software service. PostgreSQL is a software service that you tend to run and build your full stack and develop something on that and push it to the customers, right? So that is what the workload really means in DevOps engineering work. Like that's one of the crucial words. You sometimes people may say that it is a service. Okay, I would like to put both the words. A workload or service are the two most important and commonly used words in all through the DevOps engineer's work life. You see, because whatever that you run, you may be running a full stack developers, or you may be doing a big data engineering things. You have to know how to classify that as a workload. That's very, very important. Okay, now let's come to the big data. So what about big data engineering candidates or candidates who are pursuing some kind of data engineering? I'll put it this in the common. So maybe you wanted to run a kind of an Spark cluster. Is that what you want to run? So Apache Spark becomes a workload. And suppose you are willing to run some kind of a Jupyter notebook and they want, a Python application or with some NumPys and the pandas and all that, and you wanted to be an AI ML developer doing some scientific computing and all that. What is it all about? It's a workload. So you may need some real distributed cluster like Kafka, so which is an important thing in the big data engineering world, or you may be running an Hadoop PMR. So all these are workloads. Okay, all these are considered as workloads. This is the first DevOps engineering viewpoint. When you are willing to become a DevOps aspirant, when you are willing to become a person who wants to pioneer in this field or who wants to build your career in this field, the very important thing is that we have to know the platforms and then the programming data structures and then the workloads. What is a workload? That's the third place where we have to come on. And there is a fourth place for that. Okay, fourth place. So what's the fourth place now regarding today's topic? The fourth place is I'm going to get into the container topic. And then there are lots of things about it. Okay, workload, service. Then there are lots of things like automation engineering is there, observability is there, SRE is there, platforms engineering is there. But I'm not going to concentrate on more. My topic is very, very clear that what's the best learning for container technologies in DevOps. I'm not going out of the context. So the final thing is going to come to containerization. You see, generally, when we get into these kinds of technologies, we always have generally human beings have the habit of getting the most end part of something, not beginning right. Okay. When I talk to people, people say that I want to become a DevOps engineering career. I wanted to build it like that. And someone says that I want to build a cloud and all that. And the day one of our sessions, generally people ask a question, say, I wanted to know this, I wanted to know that, and I wanted to do so many things. We can't actually do it like that because the first thing that we have to understand is the process. Okay, so containerization is a process which comes at the dead last. You get the point? The containerization process, when people come to DevOps engineering training program or something like that, what they generally are more excited about is the process of container. They want to straight away jump into containers and they forget about the platforms and we forget about the programming or minimal data structure understanding and we forget about what's a workload. And immediately when you get into the tools like Docker plus Kubernetes, it is going to be like an hell. It doesn't work well. Okay. That's the most important thing we have to come. So we have to always have a process, okay, a process in which when you come to a specific technology, it's not that you come to a technology right from the beginning, you come to the technology from the last. Okay, so I put this place as for containerization. Now, our topic today is mostly on containerization. So I'm going to put it like containerization. Okay. So in this containerization process, okay, maybe it's a process, okay, and I wanted to add 4 important steps there. 4 important steps, basically. what are all the steps that we actually need to know about containerization? Okay, so I will be adding those steps. So what is the first step? There are 4 important steps in containerization. If you haven't, I mean, those who are attending this for the first time, I mean, who haven't been related with Inceptez or SloopStash for a very, I mean, are coming from the outside or something, I want to tell there are 4 important steps. Maybe the people who have already attended our training program may know all the stories, which some of the stories we have been talking today. But the people who are coming for the first time, okay, when you go to internet and learn something in the YouTube or a WhatsApp or something, never get or never take that too serious. Okay, so about containers I'm speaking, about the technology world I'm speaking. The first thing to know about containerizations is there are 4 basic steps involved in that. Okay, so these are all not the steps. These are all just the process that you have to come through to reach the containerization in DevOps. Okay, but in containerization, there are 4 steps that are actually very, very important. The 4 steps are like, the first thing is going to go for something called as OCI image building. Okay, 4th step. So the first thing is OCI image. Okay, so I would just like to put this like this. Okay, and with a good color board. I don't have much time, so I may be slightly going fast. Okay, so I need to complete lots of things. So OCI image, and then is container networking. Okay, container networking. Okay, and then we have to go through container storage, or we can simply call it as storage. Okay, storage, networking, and then we have to talk about the 4th thing, which is containers. Okay, so you see here, when you say that I'm going to involve in the process of containerization, if you are a classical DevOps engineer in your organization, you wanted to make that you progress in container, you wanted to containerize a full stack, you want to containerize a data engineering stack, you want to containerize a machine learning stack, you want to containerize whatever stack, it doesn't matter, any tech stack. The 4-step process, or the tunnel actually involves in image building, which is what we call as OCI image. Sometimes people call as Docker image also. I'm not willing to put a surprise, but this is also called as Docker or OCI image, or otherwise sometimes called as container image. Okay, and then the next thing is networking, and then the storage of container, and finally we reach the container. Okay, so this is the 4 steps. These are the 4 steps that are involved. So those who are willing to become or maybe a DevOps aspirant, willing to choose career path in DevOps and wanted to show more interest in container infrastructure. So, and this is the best way to get started. I'm not talking on how to do it. I'm talking on what is the best approach that you can have in it. I'm not going to talk about how to do containerization because that's a vast stuff. Okay. And in this place, the automation. So if you ask, so where is then the automation and orchestration? The words were not there. So the words were here. So when you do this 4-step process properly and learn this 4-step process properly, and finally you automate and orchestrate it. Automate, and orchestrate this process. Okay, automate and orchestrate this containerization process, or maybe workflow. Okay, and this is where we use tools. Okay, this is where we use tools like what the Docker. This is where we use tools like the Kubernetes. And this is where we use tools like the container. There are lots of tools in the ecosystem. On the top, we may see just the Docker and Kubernetes stuff. But the most of the time, people always jump into interested in the tools and names and all that. But that comes quite in a delayed way. Okay. And this is where, if you want to achieve this automation and orchestration of your containerization workflow, then you need what this Docker and Kubernetes stuff. Okay, so Docker Kubernetes is not something that you have to start with the beginning. This is itself is a very big stack, but I'm just trying to put it here. Okay, so just putting it here. So Docker plus Kubernetes. Okay, this tools helps you to do this process simply. And there are many tools inside the containerization ecosystem. Basically, there are tools like the runc, the containerd. There are tools like CNI, the C. I mean, many things were there. Okay, it's a vast ecosystem. Okay, we know on the top that Docker and Kubernetes maybe it's a popular stuff these days. So we know that this is important. Okay, but under the hood in the container ecosystem, it's a big infrastructure which is composed of lots of things, lots of tools, lots of services, lots of things. Okay, so we don't need to get into all that, but we need to know this process. Okay, so what is the process number one? The process number one is a DevOps engineer has to go. Oh, I'll just delete this one. And the process number one is platforms. Okay, wait, I just edited. This is the process number one. The one is platform. And then what is the second thing? The second is you need to have some amount of programming plus a data structure knowledge. The third thing is you have to have some workload or service understanding. Maybe a full stack. We need to have understanding. I'm not saying you have to be a full stack developer, or you don't need to be a big data engineer to pursue DevOps. That's not true. You don't need to be really good AI/ML engineer and wanted to pursue DevOps. That's all not true. Okay, we need to have a good understanding about the workloads and the ideas. That is what is very, very important. Okay, so this is how we get started with this workshop today. Okay, so this is something that I believe I wanted to share to people in the beginning, and I want to show some path, and I just wanted to show some lights on those who are really willing to get onto this kind of an arena. Okay, so the fourth and the final step is containerization. That comes at the last, right? So that's the important thing we have to know. And I'm going to just close off this whiteboard. I know you may have some questions here and there. I will give the time, okay? So, but I wanted to know how many of you understood this thing, okay? Not unmuting the mic. You can, wait, I'll come to the main screen. We can come to the, what is that? We can come to the reaction, okay? So I will come to the reaction and let me go to that screen. So how many of you understood this? You can click this and react. Is that understandable? What's the process of a DevOps engineer to get into the what? The container technology. So not getting started right away, but it's at the end. Okay. So I believe if you have questions, note it down. We'll discuss after the session is over. Okay. I will not take more than 2 hours. So another 1.5 hours is there. So your time is precious, and as well as my time is precious. So I get on to the next thing. That is, we're now going to go to the technical aspect. Okay, so we are now going to go to the technical aspect. So what's a technical aspect of today's topic? So we're going to see how we can develop a full stack application with basic Docker tools. I'm not going to talk more on Docker. Okay, I'm not going to talk more on how we can set up and all that, but I'm going to show more on how we simplified the development, how that can be simplified and can be useful to you. Okay, so the next topic is this one. So I'm going to talk copy and going to go down and 1, 2, 3. Okay, and putting it here. So 1, 2, and this one. And so visualizing a seamless full stack development. I will practically show how that works as well. Okay, so it's not a theory, vague theory stuff. Okay, so now let me go on to my whiteboard and I will open another whiteboard. I just close this one. So new whiteboard, create new drawing. And if you see here, the the important thing about full stack engineering. Now I'm correlating the concept of, DevOps engineering things with the full stack engineering things. Maybe some of you here could be from a full stack engineering background, or you may be from a developer background, or you may be a programmer or a testing engineer. It doesn't matter. Okay, it doesn't matter what it is, but this diagram helps you to understand what I am trying to prove. Okay, I just want the next 15 minutes of concentration on this. Okay, so the first thing is I'm going to start with something called as the host. So what is a host? Okay, and then I'm going to divide this into a VM. I'm talking about development. Okay, development, software development, or you may say testing or whatever it is. I'm talking about development, not about running some production grade stuff. Development. Okay, full stack development or Java program development or Node.js development. So I'm talking about that now. Python development. So this is virtual machine, and then we have something called as a Docker hub in the context of Docker. Okay. So let me put a small dash here. So this is the host, and then we will have a dash here. So this one, and then we will have something like this, and we will have a dash here. Okay, so we'll have a dash here, and this is the Docker hub. Okay, so we'll have a dash here. So the host, what is a host now? Maybe it could be in the DevOps engineering standpoint I'm talking. So what is a host? A host is nothing but, suppose you are having a laptop. Most of the development happens in laptop, right? So I wanted to give a definition of host. Okay, so that's the host. Okay, a host is the in the context of developer, in the context of development, the host, okay, host or host machine points the developers, the devs, the laptop, or so I'm sorry, it's not a laptop. Context of the host machine points the operating system running on the laptop. Okay, mostly a laptop or a dev machine on the machine. Okay, so that is what we call as a host machine or host. Just to give some context about this. Okay, and this is what, and this could be, and supposing some of you guys may be having their offices that they actually provide a Mac operating system. Some big companies actually give Mac OS, and sometimes people have Linux operating system. Mostly it is all about Windows. Okay, many people use Windows operating system. So when I say, in the context of DevOps engineering and all this kind of roles, we have to say host means it's the place where you do the development or which contains an operating system running on it. And that's what we call as a host. Okay, that's what we call as a host. And there are lots of explanations in the internet. You can actually try that. So when you have free time, these are all very good things that you can learn in the internet. And what is a virtual machine now? What's a virtual machine now? The virtual machine is nothing but another operating system that is running inside your host, or maybe a guest operating system, we would call like that. Okay, so a virtual machine is nothing but a guest, a guest operating system running inside your host machine. And virtual machines there are bare metal hypervisors and many other things. I'm talking in the context of development. Okay, so so there is bare metal hypervisor, so you can directly run a virtual machine in hardware without a host operating system. So that is there. Okay, but I'm not talking about it. I'm talking about the day-to-day work life of a developer or testing engineer or someone. Okay, a guest operating system that's running inside your host machine. Okay, so this also can be something like a Linux, or this can also be something like a Windows. This can also be something like mostly Mac OS people don't run in the virtual machine. So, but this can be anything. Okay, most of the time it will be Linux operating system when it comes to DevOps engineering related things. Okay, mostly Linux. Okay, or secondly Windows. Okay, mostly Linux or secondly Windows. Okay, so Linux or mostly Mac won't be there in that section. Okay, so this is Windows. Okay, Windows or Linux. That's a virtual machine. Now, I think in the context of the development and the full stack or DevOps, we need to know these words very eloquently. So that's what's a host machine, what's the virtual machine, that we have to very clearly distinguish. Okay. Now I'm going to get into the topic. Now, what are all the tools that we need in the host machine to do some development? For example, if you are going to do a development of a Java application, or you wanted to do some Node.js development, or a Python app development, or a Ruby on Rails development. So what is that you need to have in the host machine? There are tools. Okay, so what is the tools that we need to have? The tools are basically like, I would like to say IDE. So everyone uses some kind of a code editor or some kind of an IDE to accomplish that, right? So I would like to say that it is an IDE. Okay, that's very important tool for a developer. No one is going to code in the terminals and all that. So an IDE is the place where you actually write the code. Okay. And then the other tools, so you may need to have some VM building tools or something like that. Sometimes people run Linux machines and run Docker directly there. But I'm just going to plainly put that's an IDE. Okay. So I just try to put copy paste, and this is an copy paste. Oh, sorry, uh, copy paste, and this is like this. Okay. So this is the IDE. Okay. So in this IDE, okay, you used to write code, right? So you used to write code. So let me name this. This is an IDE, Integrated Development Environment. Okay, IDE plus tools. Don't need to start with that. IDE plus tools. Okay. So this is the very important thing for any developer's work life. Okay, even a testing engineer or this engineer or that engineer, whatever it may be, okay, or a big data engineer, you can't live without an IDE or some standard development tools or a VM running hypervisor or something. We can't actually do anything about it. So this is a standard one. I'm not talking anything to specifically this audience or that audience. I'm talking very standard one. Okay. Now, if you see here in this IDE tools, okay, you may be writing your let's say if you are a Python developer, you may be writing Python code, right? So let's say you are a Python developer. And so you are a Python developer. So you write that Python app code from this from this specific IDE, right? So that is what the matter is. And then suppose if you are let's say a Node.js developer, okay? So you are a Node.js developer. You are going to still write the code through some kind of an IDE. It could be a Microsoft Visual Studio, or could be some kind of an Eclipse or an Atom, or it could be something like a simple editor, like a text editor, like Sublime, or maybe many things. Okay, that's what I'm going to simulate. Maybe you may be writing some kind of a Ruby on Rails developers. Okay, so I just put few things. Okay, so that's inverted arrow, and that's Ruby ROR, Ruby app or rates. So the famous one. Okay. So if you are actually developing all these changes in your host machine, okay, where do you run the IDE most of the time? You run the IDE not on the cloud or many things. Most of the developers develop code in their laptop, okay, in their dev machine, or maybe the company has offered them the dev machine. So they write the code here. Okay. And then what actually we have to put as a crucial point is the IDE tools plus the developers who write the code is all going to happen in your host machine. So I like to put that as a point here. The black color. The developer writes code in their in an IDE which is mostly installed in their host machine. Okay, it could be Windows, Linux, Mac, anything. Okay, so this is the first important thing we have to know about a developer's work life. You could be someone from not have even developed any code in your work life. That's okay, fine. But we have to know this viewpoint as a. I mean, if you are willing to pursue your career as a DevOps engineer or someone, that most of the developers' work life is all about setting up the IDE and writing the code and stuff and all that. Okay, so we have to, as a DevOps engineer, understand their things because we are also going to use an IDE to do some stuff. Terraform code, how do you write? Docker YAML, how do you write? You need an IDE plus kind of a standard tools here. Okay, so now what's the code? Whatever code that you write in this IDE, what happens is that it must have a capability to sync to a virtual machine. Now we have to be cautious in the topic which we are dealing with. We are cautious in topic about. We have to be cautious that we are now talking about a seamless full stack development with Docker tools. That's the topic. Okay, maybe I didn't put it on the top, but that's a topic I'm first distinguishing the host machine, and then now I'm coming to the virtual machine. Okay, every developer's work life is not about just having an IDE and tools, but it is all about having a virtual machine. That's a good practice for development. You can't install all the so-and-so stuff in your host machine and contaminate it. You can't do that. Okay. If you are a standard developer, if you have a good company where you are actually doing lots of good development, brilliant companies and good companies always tell you how to build a VM, run a VM, use the VM for development, and then push it to some kind of remote repository. So that's a very standardified process. Okay. So here, when you are a developer, good developer, working in a good company, you are trying to build some code for your organization, and you wanted to sync that code to a virtual machine, right? To a virtual machine. So that is very, very important ingredient in a developer's work life. Could be a full stack, big data, whatever data. It's nothing but you have to have the knack of writing code, and immediately you see that in a VM, and it's a kind of a fully bidirectional F-sync mechanism that helps you to get the results immediately in the VM, right? So that's very, very important. Okay, so I want to put this arrowhead like I wanted to say it like sync code. I just put like this sync code sync. Whatever you do, okay, whatever you do, you should be able to sync it to a virtual machine lively in a matter of time. Okay, should be able to do it lively to the virtual machine. It's called sync code, and I would like to give a kind of a dimmy reddish color, or maybe a don't have time to choose colors, but I will try to bring some good color. Okay, or reddish is good. This is good. And this also, I wanted to add this same color. Okay, so this one, and this is also this one. Okay, so now after you sync the code in real time, this is a real time syncing code. Okay, what will happen in the virtual machine? So what's the virtual machine going to contain in the modern DevOps based containerized development? How do you do that? Now, this is the place where it becomes a bit tricky to understand. Now, this is the place where most of the people, or maybe a DevOps engineer himself, get it wrong. Okay, so what is that is going to wrong? People believe that Docker, one of the most puzzling facts is that people put code in Docker image. And some time back, I was talking about Docker image or OC image. That's one of the wrong fact that people do. Most of the companies do that. 99% of the companies do that. If your image is compromised, you are dead and gone. And that's not the way how a DevOps engineer has to work. When you are in the process of containerized development, you have to know that you are not going to put any intellectual property of a company, that is a Python app or a Rails app or a Java app, and you are not going to put it inside that. It has to be seamlessly decoupled from the container ecosystem. You get the point? If you are going to put everything into the container image and some way you're going to push it to Docker up and it's got lost. Okay, because we are playing with intellectual property of a company. When a developer develops code, a Rails application or a Node.js application or a Microsoft, whatever it is, it's all about code. And that's an intellectual property of a company. It should not be built with some container image and foolishly put outside. Okay, that's a very dangerous thing in container technology. Almost 97, 98% of the company do that in the same way. And they have a very great risk of getting their code exposed to external hackers and attackers in the internet. I mean, I don't want to deviate. I just come to the point. So now here, what is inside the VM, which is that we are going to do, how we can simplify this one. So basically, inside the VM, we're going to simplify it by having the Docker tools. Oh, sorry, this one. So Docker tools inside it. So basically, this, this one. So where is this coming? So we have the Docker tools installed here. Where is the Docker tools now installed here? The Docker tools now come inside the VM. People use Docker desktop kind of products. I don't want to deviate, but I just wanted to say that there are lots of limitations in those products. I would like to say that, okay? And that offers you, I mean, unlocking the full power of a Docker engine is not completely possible when you're going to a kind of a desktop client. That's the most simplistic or a kind of a very limited way of getting started with container technology. So the first thing that you have to realize is inside your virtual machine, you have to always have a tool called Docker, or maybe multiple tools called Docker tools. This is the first thing we have inside the, inside the virtual machine. Okay, so that's the first one. And what happens when you sync the code? Okay, so basically, with the help of Docker tools, we can build stacks. Okay, build stacks inside. So a full stack, a data engineering stack, or machine learning stack, whatever stack you say, we can actually build it. Okay, so how do you build the stacks inside the virtual machine? So I would say that it is far more simpler than what we actually think of. Okay, so basically, I just try to put off like you see here, and I just need to be right with my drawing. I need to copy paste it. Okay, so 3, 4, 5, like that. That's enough. Okay, so this is a stack. You have an IDE that you write a code, and you have a VM that has the Docker tools deployed in it. And what more you need? You just need to use the Docker tools to spin up the stacks that you want. And that's it. That's it. Okay. And that is where how we are going to simplify it becomes an important matter. You get the point? That's what we're going to see now. And in this place, I just change the colors of this one. I don't want to spend more time, but this is a stack. Okay. And we can put lots of prints like this, snap of a stack. Okay, so you can have this, you can have this one like this. So many stacks you can run inside the VM. One of the things could be a data engineering stack. One of the things could be a full your Node.js MongoDB stack. One of the so all things get the code seamlessly synced. So what does that means? Okay, how do you see that? How do you spin up all these stacks? Now we call in Docker that we see that running all these full stacks. I mean, I will just quote this one. The internal thing that you see here is what we call as container. Okay, container. I need to be spot on with my words. So this is a container. Okay, container. And this one. inside. So it's a kind of a stack in the context of a Docker or Kubernetes is mostly about something which is a composition of multiple containers to power up a stack. Okay, a stack is a composition of multiple containers or multiple OCA containers. And Docker is also going to treat it same way. Kubernetes is also going to treat in the same way. Okay, so this is a stack, maybe whatever stack you want to have, and this is a container inside the stack. Now, how do you classify that one? How do you classify that one? So this is a stack, that's a stack. How do you classify? We classify it with the name of an environment. When you go to standard container tools like the Docker, the Kubernetes, all these kinds of DevOps-oriented technologies, so-called, we say, and all those of them have a namespacing approach inside that. That helps you to clearly distinguish what is the environment it is all about. We say it's a dev environment, and I can say you can have many dev environments, or maybe it's just the name here. You can have a QAA, and you can have a QAB, and you can have, let's say, QAA, and then you have a dev environment. Sorry, this one, copy and put it here. Okay, so many stacks like this. And this dev environment is maybe could be a kind of a stack A. Okay, maybe a full stack A. Okay, it could be something. And this dev environment, and this is all also about copy, paste, and this is also about a full stack A. And this is about a full stack B. So you can have multiple full stacks running on a single virtual machine, running a Docker container engine inside that. And that's the proposed solution to solve the biggest development problem on the planet. You see? So that's how containers simplify the development. Now, many of the people in the DevOps mostly focus on containerization in the context of what? In the context of what be in the production. So how to run container grade, how to run an orchestration, how to do this, that. Yeah, that is all true. It is there. Okay. I don't say it isn't there. It is there, and it is meant to run for the production as well. But what I'm trying to say is we have to have a distinction. If you can't develop things with containers, and what's the point of putting it in the production? You see, when you are developing something, your developers develop day to day. As it's a very important, crucial viewpoint of a DevOps engineer. I'm talking specifically people who are willing to be DevOps cloud aspirants. You see here, if you can't develop something with the containerized infrastructure, how are you going to match it with the production in container infrastructure? Could be a Kubernetes or Docker cluster. It doesn't make any sense. And that's why one of the important reasons is you find the development to production porting or releases becoming so difficult in even good companies. You see why it is becoming so difficult? Why it is becoming so difficult? Because people couldn't correlate the containerized development with, could not correlate, build a containerized development infrastructure in a seamless way. Hence, there will be lots of struggles in taking that kind of an infrastructure to the production. And so we are always puzzled with that. And we have lots of nightmares in using Docker, Kubernetes, and so-called container infrastructure tools, and we always struggle with it, right? So this is the place where we are where we are now trying to solve. Okay, so this is, I believe, in the pictorial representation, I can be more providing more clarity for you. Okay, so maybe you can say dev test, something like that. So test, or that can give you more context than this name. Okay, test or TST test. Okay, so you can have multiple environments like this. So it's all what we call as an environment. So we need to have the clear naming approach. If you say this one, what does this mean? It's an environment. Okay, it's an I just try to use a different color. This is an environment. Okay, an environment of what? Environment of what? Environment of a full stack in the context of a full stack engineering. Environment of what in the context of big data engineering? It's an environment of a big, maybe a big cluster or something that is running inside the virtual machine. That doesn't matter. Okay. Now, the main point comes here. So when you are doing this kind of thing, how in the world we can accomplish this? That's the whole point. Maybe it could be look like a kind of a little sweet, neat thing that we can actually, or that people get surprised when I show this kind of stuff. And yeah, we can actually get you do it and it works. But that's not a joke. Okay, that's not a joke, and that takes an humongous effort to do this one. Okay, so it's not a joke. If you are even a good people who are have lots of knowledge in DevOps engineering, the Docker, Kubernetes tools, always find it so difficult to correlate their development infrastructure to the containers. And always it has been a big struggle. Either they go in the wrong way by putting all the code in the image and flourishing it to everyone, and that's a wrong practice. So how do we accomplish that? And this is where we have come up with an idea. Okay, now you see this is a very classical looking thing, and we are going to come up with an idea. So what is the idea that we have come up in SloopStash? In SloopStash, we've been dealing with all these things for a very long period of time. And I personally have been managing and running containers for more than a decade now, ever since the release of the Docker GA in 2013. So I've been doing all these things for so many times, maybe more than a decade I've been doing this. And what I wanted to say is we have come up with a solution for this problem. It's a solution. Could be something that you want to try in your organization. After seeing this, we put all the things in open source so you can take it. So how we can accomplish this kind of a seamless development platform so that your production releases will not be barred always. Okay, so how to use containers to the maximum potent. That's the solution is all about. So we have built, in order to make these things work like smooth piece of cakewalk, we have built something called as a SloopStash Docker kit. Okay, we call it as a Docker starter kit. Or maybe we offer lots of kits. Okay, so not kids, it's kits. Okay, so we offer a lot of kits like that in the open source. I will show that. But if you see here, it's available in GitHub. We use this kit to power up these stacks for seamless development. And that's what is a prototype which I'm going to show. Okay, so what is this kit is going to do? I just try to illustrate in here. Okay, the kit is going to how we have simplified this thing is we have tried to this kit through this kit, and the kit contains all the important ingredients that is required for running a full stack operation, the development operation, or maybe a data engineering stack, or anything that you want. We can customize that. Okay, so what it is going to contain, this is something which actually contains contains the code configuration and templates and etc. related to code configuration, templates and artifacts required for this for seamless software development. So that is what the kit is trying to offer. It's not just the Docker kit which I'm talking about. There are so many kits that we've been doing in the open source arena these days. If you can go to the GitHub and see what we've been doing, you will be able to understand what I'm talking about. Okay, so this is the starter kit which I'm talking about, which helps you or powers you up your development platform very simply. And that is what I'm going to demonstrate after some time. Okay, so using the kit and using the Docker tools, you can very comprehensively, okay, I think I need to put an arrow head here. Okay, you can very comprehensively run all these full stack effortlessly without any effort. You don't need efforts at all to accomplish this one. Okay, maybe I think this is right. Okay, so that is what we are trying to promote. Okay, so you can effortlessly run any kind of full stacks, data engineering stacks, or any kind of things without any puzzles. Okay, and how do we do that? Means we actually build all the things. Okay, you may be a Node.js developer. You could be a MongoDB. You're doing some POC in the MongoDB. You could be doing some kind of other things in maybe a PostgreSQL or Elasticsearch. Maybe a full stack engineer is well versed with all that, or maybe a MySQL, or maybe a Hadoop cluster or something. So there are lots of things that people work a full stack engineer. So we supply them all that they are required. So we supply them the container images, okay, pre-built container images configured to run with the kit, okay, to simplify your development process. So our proposed solution for containers, I mean, if I tell a person to do this on their own, it takes a lot of effort and time to accomplish that, right? So, but we are trying to offer a solution that you can take open source, you can take and run it on your own, and you can have, suppose you wanted to have an Elasticsearch. So we will have a, sorry, I think this doesn't work. So I just put it like box. Okay, that is better. So you have an Elasticsearch to run, or maybe you want a MongoDB to run, and you want any other workload to run. So all those workloads contains a pre-built Docker image, which is available in the Docker Hub. Okay, and you can also customize it. We are not offering anything that you can't customize. So you can take this. And you can customize all these things like how you want. And the kit helps you to seamlessly spin up all these things. So that is the matter here. Okay, so because we are dealing with the development, which is somewhat not that easy to set up always. Okay, maybe you may have some limitations in that, or you may have some kind of a thing that you can't accomplish in that. So there are lots of things like that. Okay, so we are offering lots of configurations and many other things seamlessly that you can just take and run. That's it. Okay, take and run. That's it. That's all. Okay, so nothing new. Okay, nothing very difficult. Okay, so these are all the workloads. Okay, we try to provide, and you can customize all these things. You can use this as a framework or a platform or something like that to build your own full stack engineering development. Okay, so this is our idea of solving this bigger problem. Okay, so and I would just like to copy this one and put it here. Oh, sorry, and copy and paste. Okay, so here and put it like this. So the stacks that we are seeing here are powered with the images from this place. Okay, so like this. Okay, so these are all basically nothing but the container images or OCI Docker images we offer. Okay, anyone can take it, anyone can customize it, anyone can make it according to their organization. So that is what the kit actually offers. Okay, that is what the kit actually offers. And I just try to distinguish some colors here. This one, a bit of a color. And this one is a bit of a color. You need to add some good colors. Okay, databases thing, and you can have some coding things. Okay, so all those things are now available like that. So there are lots of other things as well. Okay, so this is how we wanted to simplify the development. And when you do it in this way, what are the benefits that you can get out of this development? I just wanted to quote few benefits. Why not scaling down? So when you are building something like this, okay, so we need to know what is the benefit of doing something like this. So the benefit here is that we are going to have a good debugging capabilities. Okay, when in a containerized development, we can customize the kit like however you want. If you know some parts of Docker and understood something, you can go download this and change anything like how you want, and you can run your own custom configurations in it. So it is all going to be much more simpler. Okay, so what are the two things that we can accomplish through this? The first thing is I wanted to say that you can accomplish effective debugging effective debug debugging and containerized effective debugging and containerized development platform. And then you can have, so this is the important thing if you are building any code or something. Okay, so the first and foremost important thing is you should be able to know how to debug it. The environment has to support all the things. So these are all very, very important stuff to remember. Okay. Oh, that arrow got stuck inside the middle. Okay, so it's like that. Okay. And then what is the next thing that we are going to worry about? And the second thing is you can customize anything like how you want. The two important points which I wanted to make. I will make it red. Okay. Two important things you can actually get out of this this kit is that you can have containerized development with the debugging features, and then you can have customization on top of it. You can customize it like anything. So customize your development, your containerized development platform like how you want. Okay, so that is what we are trying to show now. Okay, so I believe this is a kind of an proposed solution for the problem with containerized development. I have taken a classical case of a full stack development, and I'm going to take a small, we have a small Python full stack. It's not a very big full stack, it's a small full stack, and I'm going to just show how that works. Okay, so you have the code, write the code, sync the code to the VM, and have the Docker tools deployed. And the kit helps you to spin up multiple stacks with the dev testing and whatever you want. And you don't need to do anything about it. The OCI images, or what we call as the container images, are supplied through this chain. So download, container image, or maybe say Docker images from Docker Hub, download Docker images. Okay. So like this, you can easily complete this process. Okay, so I just have to put it gray here and here. Okay, download Docker images. So this is how we can beautifully set up a containerized development. Now, this is not just for full stack. When I say full stack means people always take it too literally that this is going to work only for full stack. But I wanted to say this works for data engineering stack as well. Okay, and that's the important thing. So now, how many of you understood this matter? Now, is that understandable? Can you guys react here? What we are trying to do? Okay, is that a bit interesting, or it's a kind of a boring stuff? Okay. Anyhow, so you can't understand fully, but what you can understand is you can understand what's our viewpoint on solving a problem and real-time problem in an organization. We are not talking about something which is a demo application. Okay, so that's too far. We're trying to solve real-time problem with a real-time open source, real-time development and all stuff. Okay. Now, what I'm going to do is I'm going to bring this here. Okay, so that is here, and that's this one. Okay, and I will share all these things in the group once this is done. Okay, you can try this kind of things in your organization, and all the things will be shared. So now I'm going to demonstrate how we can do that. Okay, so I'm going to demonstrate how we can have multiple environments. Now you can see in the picture, I'm going to run multiple environments of a stack. Okay, here I told 2 stacks. As of now, 1 stack is ready with us. So multiple environments of a Python application. I'm going to do some coding and I'm going to show how that is reflecting in the containers that is running inside the virtual machine and see the real-time results. Okay, so please concentrate. This is concept. The concept is covered for you. Now you have to concentrate on how that is done. Maybe you can't understand it fully because it takes time to implement. Okay, but just see how that works. Okay, so now please carefully see. First step is I have my IDE and tools. What is the IDE and tools which I'm going to use? Is I'm going to use a Sublime code editor. Okay, this is a Sublime code editor. And it's not a very comprehensive IDE, but it's a good code editor, which I practically like. And I'm going to open my code. Okay, so I'm going to I have a app called SloopStash CRM app and many apps like that. And we have lots of starter kits. Okay, so you can ask me from where these kits are coming. So these are all the things which we have open sourced for the benefit of us, for the benefit of the community. So this is our GitHub SloopStash account. You can actually find this, and you can find lots of starter kits for Docker, Kubernetes, and AWS and all that. And you can see there are many forks and things have happened in that place. So if you want that, you can click and fork it and you can develop on that. So I'm primarily focusing on this Docker starter kit now. Okay, and this is the kit which contains the Docker files required to build the images, OCI artifacts, container images and all, and required to build all the data engineering stacks and full stack infrastructures in the development. Okay, so I don't want to talk more about it. You guys go and verify whatever you want, take it and customize it and spin it. Okay, that's your job. Okay, so I'm going to now get onto this place. Okay, so I'm going to now first, I have opened this in the code editor. All the GitHub sources were now here. Okay, loaded here. I'm going to now run a Python Flask application. I'm going to develop a Python Flask application. I'm going to show how that is reflecting in real time. Okay, so this is a Python app written in a Flask framework. Maybe some of you may have known that who are in the data science and AI engineering or Flask, you may have seen. Okay, so that one. Okay, and I'm going to now then go to the next step. That is, I'm going to spin up my VM. So the first step is the host. The second step is the VM. The third step is the stack powering. Okay, so 3 steps are there. So I'm going to start up my VM. So I'm going to basically go here and go to my one of the VM which I've already built. Okay, using Vagrant tools. That's a tool to power up VMs. And I'm going to start it. Vagrant, Vagrant up. Okay, so that is this, say Vagrant up. And that's the one I've configured. So I'm going to just say Vagrant and do it for server and Vagrant up. Okay, so this VM will be up and running. And this is something which is a source from this Kickstart Linux. If you want to know how to run VMs, as I said, we have lots of starter kits. You can go here and help yourself if you want. We actually have a Linux starter kit. And this Linux starter kit actually powers up lots of Linux virtual machines. Okay, we provide a customized platform for lots of operating systems in Linux mostly. And for Windows also we have, but Linux mostly we maintain very frequently. Okay. All the things which I'm talking about, the container images which we are going to use after some time is available in the SloopStash Docker Hub. So you can see here. So this is all available in the open source. So if you run the kit, you will get it. And the VM machines and all the things we have been doing is also available in the HashiCorp Cloud platform like this. It will load after some time. So you can get the custom VM platforms, you can get the custom container platforms we have built, and you can spin up your full stack development in no matter of time. Okay, now I have configured it. So my VM is now up, and I'm going to now SSH to the VM or log into the VM. Okay. So I have now logged into my VM, Okay, and this is my virtual machine. So it's a Ubuntu Linux machine. And I'm going to once do some small hack. It's not a hack, that's an important thing to mount my code from the host machine, okay, to enable code sync to the virtual machine. You see here this command. What I'm trying to represent here is I'm trying to sync my code from the from the host machine to the virtual machine first. Okay, that's why I run that command. And then what I'm going to do is I'm going to first power up a full stack. That's a small Python Flask based, Redis based, Nginx based stack. Okay. So in order to power up that stack, in the Docker starter kit, there is lots of models. Okay. If you see here in the wiki, we have constructed lots of stacks like Node.js, Python, Ruby on Rails, Hadoop cluster, Kafka, MongoDB, Redis, many things were there. Okay. So it's in the wiki, anyone can try it when you're free. Okay, so I'm going to go to this Python Redis Nginx stack, which we call as a CRM stack, sample application. So in this place, I'm going to first go here and set my environment variables, okay, in the shell. So that's the second step. So I'm now setting up this one, okay. And then that's environment is dev. And I'm going to say, I'm going to start up my containers for the environment that you can say of your full stack. So I go to the Docker starter kit. I have already cloned all those kits here. Okay, if you see the kit here in this place, okay, someone is unmuted. Please mute your mic. Okay, so we see the kits here, the Docker kit and all here, like this place. So that is what I have downloaded and I've set it up. Okay, maybe in the class time, I know it's a session time, we have less time, so we can't do everything. Okay, so we have now, we are now inside the kit, and you can see here, this kit contains this lots of things like the Docker files and templates and things required to run many full stacks. Okay. So, and what I'm going to do is I'm going to now power up my stack. Okay, so according to this wiki, so I just go here and run this container compose, Docker compose is a tool. I'm going to up my containers here. Okay, so you can see that it is now running some, three containers. One is it's a small full stack. So you have a Python app, and then you have a Redis database server, and then you have an Nginx web server. It's a very small stack, not a big stack or big services. And you can see here the containers running. Okay, so whoever unmuted, please mute your mic. Okay, so so you can see here the Nginx, Python, and Redis is running, and three containers are running. It's a small stack, okay, not a big one. So just one container per workload we are running here, okay. And you can ask me how these images are coming. So you say we have a Docker images list, and basically you see Nginx, Python, Kafka, and all that. So it's all from the Docker Hub account which we have, okay, so which I already showed here. From here only it is all coming from the Docker Hub, okay. We build the images and push all the images to the Docker Hub, and when you run this command, it will automatically pull. I've already pulled that, so that's why it is here. So now what I'm going to do is I'm going to access this app from the browser, okay, so using this URL, okay, that is this one. This app dots this one. Okay, I've already put the host mappings and all that, so I can easily access that. Maybe this can be too much for you, but just see how that works. Okay, just see how that works. So, oh, not this one, this one. Okay, so you can see this is the app that is being loaded. It is a Python Flask application. Okay, that is now powered by the containers that is running inside the virtual machine. Okay, so I am in the context of virtual machine now, and now I've spinned up a dev environment of my full stack. Let's say stack A, or we call that as a CRM stack. Okay, so we've now spinned up this one. Supposing you wanted to spin up another stack for A/B testing or something like that, because a developer needs to have the sophistication of powering up multiple stacks. We may need to do some testing in one stack, development, one stack you wanted to do something. So we are allowed to run that. I will show it after some time. Okay, before getting into that, I'm going to just simulate Okay, I'm going to just simulate how I can write a code and that reflects in my development environment like this. Okay, this is loading from my containers. Okay, suppose if you are not willing to accept it, I would just like to go here and we can just stop it one. Stop this one. Those who have questions, please note it down. We'll discuss detailedly. And if I just run it and you can see that it is loading and broken. So which means you can understand that is still it is coming from a containers. Okay, that is set of containers running inside the virtual machine. And now this is all powered by our Docker starter kit. So this is not something that we actually develop for us or for everyone. It's a common generic thing. The kit contains all things. I didn't do anything. I just came here and ran the command from the GitHub wiki and it powered up the stack. That's all. Okay. So now I'm going to code. Okay, I'm going to do some changes in the code and see if that is getting reflected. For example, I'm going to say change this template. Okay, so let's say I take this Sublime code editor. You need to know that this ID is or the code editor is in my host machine. So I go here and just like that, I wanted to customize some this HTML Flask Ginger template. And I wanted to just say this customers, this is the thing. And say this is list of customers in this. And I just save this one. Just save this. And immediately, if you see here and I refresh it, it just changes. Okay. So you see here, I'm just trying to write a code here and you just refresh here, it's working. And suppose if you want me to say write you, if you are a Python programmer, you wanted to write a code, okay, Python code. This application contains that code as well. You see here that I wanted to, let's say this is the user dashboard. Okay, so I wanted to show something apart from this. Let's say I wanted to show some kind of an error.html, not this one. This is a controller in Flask. Okay, so we are writing Flask Python code. Okay, and I'm just trying to change this one and refresh this. It says it's an error. It's loading an error template. So you see here, I didn't actually do any efforts here. I'm just trying to write code and you can see the code is now reflecting inside the VM and that is reflecting inside the containers and that is reflecting in the browser. You see now I'm reverting back my change. So save that and run it. Now runs. You see how that is set up? There are two things which I have in the VM. Okay, I have to be honest and frank. Please listen carefully. This is very important for who are data engineering or full stack. So the testing engineers, please see properly. DevOps aspirants, please see. So this VM contains nothing more than two things. Please listen carefully. I'm again repeating. This VM contains nothing more than two things. One is the Docker tools and one is the SloopStash Docker kit. Two things is what it contains actually. Okay, rest of the things which you see here, the code and the images, all are coming from somewhere. Okay, the VM doesn't contain or come with the code and all that. It just has a Docker container engine deployed inside that. So it's a 24.0.2 Docker suite. And then we have the Docker starter kit deployed here. So you can see here. So this is our Docker kit, that is Kickstart Docker. And that is all making the difference. That's all. Okay. There is nothing that I have done to make this work. Okay. When you are having free time, when people ask, how do I actually take this and try this? All things are open source. We have open sourced almost everything. You go help yourself, go to the Kickstart Docker and SloopStash and click the wiki here. Get started with it and run whatever stacks you want, power it up. If you want to build this Linux VM, we have a solution for that. You click here, you go to and build the VMs that you want, and how many VMs you want. You can build any Linux you want to build. You can build. All the resources are right in front of your eyes in the open source. You can help yourself out to this. Okay, so this is how we actually make this development process work. So whatever you write, that's why I'm not a good fan of encouraging Docker desktops and all that. That is good tool, okay, desktop client. But when you know how to set up it in this way, whatever code that you write is seamlessly synced to the virtual machine. And we are just using some basic Linux skills here to make it work. And it's now in the real time, you are able to see the code changing. Okay, like however code that you write, it will be syncing and reflecting. And there is an auto reload mechanism in the Flask application Python server that just loads it like that. Now, if I wanted to reset what I have done, I just need to go here in the template and I just want to put things back like how it was, just like that. And you go here and refresh, it just changes. That's it. So that's the way how we do it. And this is the way how we develop our products. If you see here, I've been talking about our Sloop engine product, which we've been building. And we use the same technique to build a containerized development for all the product services that we've been building. Okay, it's not just for putting in the open source. Whatever we've learned, we are trying to open source, hence the community can benefit out of it. That's what we call as a giving back to the community. Okay, so this is how you can do a seamless full stack development with container engines. Okay, you can see now a small prototype of it. And I want to conclude that with multi environments. I mean, you see here sometimes there are many reasons why you are not comfortable. I mean, okay with the dev, you need more environments to do that. How do you simulate it? So you have a full stack that is running. Okay, that is you can see here it's a dev environment, and you wanted to run more environments of this full stack, or we call as a multi-environment stuff. How do you do that with the Docker? The kit supports that as well. If you see here in this wiki, it's a very simple thing that you go here and you run this let's say, and set the environment name to some other text, like allowed values are there, and you run the same command. The same command, you can see another stack is getting powered of the same environment, of the same full stack. Another environment is getting powered of the same stack. Okay, you see, one environment, another environment. So Docker distinguishes it with certain namespaces. You see, like that. And that both the things doesn't interfere together. You can see here, I can access the QAA environment by running this thing. Earlier, I took the DV environment. If I want to run the QAA, and I can say it like this. This is another environment. This is one environment of the same CRM full stack with Python-based full stack application. And this is another full stack, which is having the same thing, very same thing, but another application, another stack, another environment. Another environment. And here you can create your own stuff. It does not contradict with this. So if you want to do some A/B testing as effective as a developer, you may need more than one environment of your full stack. How do you do it? And that is what we actually showed here in the snapshot. You can create copycats of multiple a full stack environment. You can create as much amount of copies out of it. Okay, and you can beautifully develop like how you want. So it gives the developer a good freedom. Okay, so I'm going to just try to put something like, let's say, maybe GitHub. Okay, support at github.com and 491, something like that. And website is https://github.com. And this is GitHub open source platform. Okay, it's like that. And this doesn't contradict with this one. This is different, and this is different. Two both different environments of a single full stack. And a developer needs more. What he needs more than that, if we can parallelly develop, have multiple environments and have so many copies and try A/B testings there and run so many things. So this is how container technology can seamlessly power up your environment. Sorry, development. Okay. So how many of you, I mean, you can't get it technically right in day one, but how many of you really understood what is in the practicals? Is that understood? I mean, can you react there? We can ask the questions later on. Okay. I still have 20 minutes time left in the clock, so I should be able to close it. Okay. So I believe all of you got something, okay, on a seamless stack development. Now, I'm going to do the same whiteboarding. Okay, suppose if you are a data engineering guy, so what you can expect out of this? I just want to take the same kind of things and I wanted to show it for, I'm not going to do a full scale whiteboarding. I'm going to copy paste something and I just want to cover that because 20 minutes left in the clock. This is too less time. Okay, so I just try to put it here and we can have some 1, 2, 3. And then I just copy this same thing. Okay, I will just do a copy of the same thing. That's this one, right? This one, and duplicate it. Okay, and this one, I will just try to customize it according to data engineering pattern. Now, when you are a data engineering developer, now the audience is data engineering people. You are an AI ML developer or someone who wants to take advantage of the same thing. Okay. At the end of the day, what you're going to run is basically a workload. Okay. I'm going to just rewrite this thing. Okay. So I wanted to say this is a full stack A. I just want to say data stack A. Okay. Data stack A. And this is a full stack here, and this is a data stack here. I'm just renaming. Okay, this is a full stack here. I'm going to show that as well. Data stack A, and this is a full stack A, and this is a data stack A B. Okay, so like this, you can have stacks. Okay. Now, according to this, here you may be writing a Spark app. Okay, you can write a Spark application. You can be writing some kind of a map reduction functions and your mapper applications. Okay, so and then you can be writing some kind of a pipeline, data pipeline application, pipeline apps. Okay, you may be writing. We don't know. We need to constitute. It's like we write using that, right? So your mapper applications or real-time streaming applications or any kind of data engineering oriented applications, all that you need to know is you have an ID. And what do you do? It syncs the code to the VM and you can seamlessly run it. That's what we've seen, right? You can have a dev test kind of thing. And what more you need from this area, from the kit? It's not just going to be an Elasticsearch. It could be instead of a MongoDB, it could be a Spark. Okay. So instead of PostgreSQL, it could be in Hadoop. Okay. Instead of Node.js, it could be a Kafka. Okay. It's not instead of that. Kafka is a different thing, and this is different. Okay, I'm just customizing that same diagram which we have done in different terms, and this could be something like an so and so what. We may have some kind of Redis cluster. You may want to run some other things, so you can have some Redis. Okay, so Redis cluster. So this is how you can control all these things. Okay, so we have built for that as well. Okay, so when we solve, when we provide solutions, we don't just provide solutions only for a specific group of audience. We provide solutions for so many people. Okay, so you can run your data engineering related things as well using the same starter kit. It's the same solution. Only the workloads become different. Data engineering people don't write Ruby on Rails application, right? Or Node.js application, React application. They don't write that. So we have to give some other different test for them. That it's a same flow, same kit, same thing. And if you want to see something like that, I just want to put that in the demo. Okay, so if you see here, I come to the whiteboard and I load it here in this place. And this is the thing. I have to close soon. Okay, so I can't drag much bit. So I'm just trying to put this here. So this is for a data engineering candidate. Same solution. I'm just copycatting that. Okay, I could write Spark application, Mapper applications, data pipeline apps, whatever AI apps, or you say that anything that you want to run. It's the same flow, same sport sync, same thing, same that, same this. Nothing changes. Okay. But one thing here for, which is not suitable for full stack developers is that you may need to have the real-time multi-node clusters. So that's what the challenge when it comes to people who are dealing with the Hadoop. We are dealing with the Kafka, Spark, and all that. You may want to run something in a clustered mode, in a multi-node mode. Okay, not single node. Okay, multi-node Elasticsearch cluster. And that is the case when big data engineers or data engineering candidates usually fumble in the DevOps technologies. That's where the puzzle is all about. It's not the full stack engineers. But when it comes to data engineering point of view, I just wanted to say that we proposed the same solution. And I just wanted to show some small glimpse of, for example, I wanted to run a Kafka cluster. Okay, a Kafka cluster. Okay, and parallelly. So this is a full stacks. Okay. And then I'm going to run a Kafka cluster, and I go here to this wiki. And here you see here, there's a Kafka cluster for a data lake project or stack up. That's for different use case. So I'm going to just take this dev, go here and just put it here right in front of your eyes. And then I'm going to just spin up, run this command. Okay, so it's all from the kit. I didn't do anything. If you notice, the least thing I've done is install Docker and clone the kit. Okay, so now you can see the 6-node Kafka cluster is built and ready in Docker with Docker. Okay, and you can actually see sudo docker container ls. You can find that we have a 6-node Kafka cluster. Suppose if your hardware is adequate, you can run another environment of a Kafka cluster. 6-node Kafka cluster is a very comprehensive cluster. It's not some tiny single node development thing. I'm talking like, if you see the topic which I've given here, this is something like it's a without compromise. There is a word called without compromise. If you are going to be a big data engineer or a data engineer and you are running a monster data engineering cluster in the production, okay, in Redshift, in Amazon Cloud, Amazon or Azure or any other place, okay, you want to have some prototype of that exactly equivalent in your development, right? So that's how it becomes very seamless and smooth. And we are trying to offer solution for that as well, that you can bring your data engineering related things, like how you run. Maybe there could be a 100-node Kafka cluster, we don't know. But here you can at least have 6-node Kafka cluster with 3 controllers and 3 brokers. That is more than the thing that you want to do. And if you want to see that if that is working or not, I will just take a small shell access to the Kafka cluster. It's all open source. You can try it. And I just try to run it. It is for data engineering candidates. Others can forget about this one. Okay, just taking an access to the Kafka's metadata shell. Okay, so you see here, and I take that access, and you can see here, I'm loading the Kafka shell and listing all the brokers here. If you want to do more functionalities with Kafka, you can see 4, 5, 6, 3 brokers were listed here. There are 3 brokers and 3 controllers. So this is how you can quickly form a cluster effortlessly. It's a multi-node cluster. It's the same way how you can do with Hadoop, but I believe there is a bit of a less hardware in my VM. If I spin up more than this one, I think I will be down in the VM. It's a 6 GB or 4 GB VM. Okay, so how cool is that if you are going to go for containers for development? I'm so far concentrating not on containers for production grade. I'm talking about containers for development. We are not focusing on that one. We're just focusing on development. If you can develop with containers, you can easily take it to production with containers. And Docker allows you to do that. Okay. So right now the time on the clock is 10:50. I think I have fairly demonstrated what I want. I don't want to put more stress on that because this is all new technologies to many of the people. I believe all of you got the concept right. Okay. Technical implementation, don't worry. Everything is on the board in the open source. You can try it when you have time. If you want to have support for this, we will help you to get the support. You can find all the things that you want and all that. So, but final conclusion is a developer, a full stack developer can have multiple environments. A big data engineering developer or someone who can have multiple environments of multi-node clusters like Hadoop, Kafka and all that. Go and try it. Go and try it and use it. That's how containerized development becomes a sweet piece of cake if it is handled properly. Okay. So I think I have to wind off. How many of you understood this matter? Concept. I showed two explanations. I showed the demonstrations. Is that understandable? Okay. So I'm going to now halt my session. So my talk is over. As I told, 11 o'clock we'll finish. So I did bit faster and I did complete it. So those who have questions can now come and ask. I'm willing to answer, even if it is going to take 1 hour. Whoever came for the session and stayed this long, I really want to thank you for supporting this initiative. Whoever has questions, you can unmute and ask. You can be free, okay? So my talk is done. I closed very properly in the time, but you guys have to be vocal.
John, you used your Sublime and you edited the code and should show to show us a demo, like you modified the word customers and list of customers, and it's been automatically mounted and it reflects in the VM. So in general,
Can you be a bit vocally loud, or else I'll just connect my headset. Please wait. I was just
okay.
Not having lots of noise around this. But yeah, please proceed.
So John, to demo us, what you did is you modified the code and it will be synced to the container and it will be reflecting immediately. I mean, to the, you browse, refresh the browser and showed us like you modified the code and reflected. Okay. In general, in the live, I mean, in the actual dev team, like they used to use what is it that in our team, I mean, dev team, I'm not part of it, but they are using Azure DevOps. Okay. They used to push the code in that way and that actually goes into the container, right? I mean, that's how it usually works, right? This is just for the demo, whatever you showed us.
Okay, so you are you are trying to ask your company is trying to use some Azure DevOps or something, right? That the service. Okay, so doing some development infrastructures. Is that correct?
Yeah.
Okay. So when you come to development infrastructures, if you are a company, you want to give full freedom for the developers to have. I mean, there has to be some freedom in development. Okay. When it comes to development on the cloud, it always has its own restrictions. Personally, I don't prefer the ideology of developing something on the cloud itself. Okay, most companies actually have this practice. They have their remote workspaces and all that. But it is too limited. Many places you get lots of bottlenecks and that things work, things don't work. I believe the full freedom for a developer is in its own host machine, in its own laptop. And the job of a DevOps engineering candidate is very, very important that he has to satisfy the developer with the adequate tools and the approaches required for a seamless development in his own hardware. That is his dev machine, the laptop that he is holding. Cloud-based things, where it becomes so pointless is because many companies try that because they offer some ready-made solutions. Okay, but the problem is they have to bleed lots of money if something is not properly shut down, if something is not right, if something developer makes a mistake, they have to bleed a lot of money in cloud infrastructures. And that is usually very much unimportant because, containers, we discussed that, right? I think yesterday in the class time or something, you build an image that runs anywhere in the cloud, on-premise, local dev machine, anywhere. So then what is the point of getting onto the cloud always, right? So that is why those things can be reduced to have a very fluent development experience. Avoiding cloud is what we prefer for development. Okay, Ajay, is that understandable?
Yes, Sean, but my question is like, I just want to understand the real time, how the developers used to, update the code and push it to the container. So just.
Okay, you want to technically know how this is happening here or cloud?
Wherever it is, whether it is cloud or on-prem.
Okay, here technically, okay, in the cloud we can't show it now. Okay, so that is through a pipeline and all that. Okay, but
Yes.
here, if you see here, whatever I have done. Okay, so if you can see here in the virtual machine which have been running. Okay, so it's not actually here, but I will open a new tab. So in this place, okay, so this is the VM I actually powered on. Okay, this is the place where we have the configuration. I just opened that that configuration file. Okay, so here you have an entry called this one. So syncing, it's a folder sync. Okay, so you have something like OPT source. This is the host machine path, and this is the container path. Okay, and the host machine path, whatever you put in here, maybe your ID that you are using here, that is this one. It is all writing and reading from this host machine path. Okay, it's a real-time sync. When you expose a real-time sync from the host to the virtual machine, the code will be immediately available inside the virtual machine path. This is the host machine path and the virtual machine path. Your ID writes and reads here. It doesn't know what is happening inside the VM. Okay, but the VM's file system sync operation will always pull the code. Whatever you have read and write, it will be available here. This is technical implementation. Okay, whether it is Windows or for Linux, it's the same story. Okay, and immediately when the code comes inside the inside the virtual machine, containers can access the code because containers runs inside the virtual machine, right? So if you ask me how that is available, you can see here in the Kickstart Docker, in the Docker starter kit, we have a place called, you can see here in the Kickstart Docker, you have a place called dev.env file. Okay, so this is the place where we tell which code. That's what I'm saying. Technically, I didn't explain how we did it. But the kit contains a place where the code is synced. So when the VM code comes to this path in the VM, it will be automatically loaded by the containers, and the programs running inside the containers automatically look up for it, and changes will be immediately reflected in the code. That's all. So only two mappings I have showed. One is in the virtual machine level, which is this one. Okay, host to VM, and this is in the containers. If we are running any containers, you can see map the code here, and this is all passed to the Docker Compose template, and that picks the code and loads it inside the container. That's all. And that's how it works.
Got it, John. Okay, Demo has two applications. Both are isolated, right? So one application do not know about the other container. Each are two different, right? Yeah. Okay, so how the implementation, how are we exposing to the outside world? So that concept will you be explaining here on the other session?
Okay, that is okay. Implementation level, it needs a lot of container understanding. Okay, so this session is about giving the concepts and awareness what it can actually produce. Okay, this is an end result we are seeing. But doing this process, if someone asks, how can we actually do that and how it all works? Maybe we have to go through the process of this, the image, networking, storage, containerization. The process is there. Okay. So we learn certain tools on how to make it. And that is how this actually works. Okay, Raji. So we can't completely see what is Docker is trying to do from end to end. but this is a solution we are proposing to developers. Okay, so they can take and quickly start it, and you don't need to worry about why the code is syncing. It's a good thing that code is syncing, and you write something, it works, and everyone can try it. That's all. Okay, and customize it. When you learn Docker or these kinds of tools bit, and you can go ahead and customize the kits and all that, and you can get your thing done with it.
Okay, and to reproduce the same, I can use the same Docker kit and I can do the customization in my local and I can play around,
Yeah,
right?
yeah,
Like, yeah,
yeah.
it's okay.
That is why it is all made open source. Anyone can take it, customize it, put it in your organization, run it on cloud or anywhere. It's up to us.
Okay, thank you.
Hey John, I understand.
Hello, if you guys have question, you can ask.
John, I understand that this is a proposed system for the free source by SloopStash. We can use it directly. That's what you are saying, right?
So we are actually trying to say not about containers. We are trying to say that there is a solution, and we can use the solution to accomplish something.
Yeah.
Okay.
We can use your setup, everything. It is already there in the
GitHub
source, right?
Yeah, GitHub.
Okay, in the GitHub. Okay, so I can take that, the configuration, everything. It is available.
Yes.
Okay. Is it with the open? It's in the Git. Okay.
GitHub. Maybe I will be sharing all the links and this whiteboards and everything. In that time, I will share it comprehensively. But as of now, if that is needed, I will just take this one and I will put it in the chat. Okay. So.
So you have made this, okay, from the SloopStash. You can take this and like a package, you can take that and use.
Yeah, take it. Yeah.
Okay. So we don't need to.
And suppose suppose. Yeah.
We don't need the host and the running machines, all those things. We just need to configure, or you are asking to run the things in your environment, whatever you want.
Not in our environment. This is all something that we are having a virtual machine and running it. Like this, if you want to build, right from the start of the wiki, if you see the Docker wiki, which contains all information, here you can see here in the wikis getting started. Okay, there you can see how to even build the VM. We offer that VM solutions as well. If you can see here, we offer different Linuxes and all that. So when you use the Linux starter kit, it will help you to build the VMs. Okay. When you use the Docker starter kit, it will help you to run the containers. Okay. So this wiki, if you go here, you can help yourself. If there is any issue with the fsync, because sometimes this symlinks code sync directly don't happen with the virtual machine and the host machine. So there will be some glitches there. We need to fix that. But apart from that, as a whole solution, you can try this one, and you can see how that is spinning up. Okay. In your own laptop, you can try it.
Okay, yeah, got it.
John, one quick question, John. If I want to run multiple packages in same VM, right? Like what we have built up, like SloopStash 18.0 for Ubuntu. So can it accommodate all the packages? I mean, for example, big data stack and other stacks, or shall I need to increase it, the capacity of the VM? Like
you can increase the capacity of the VM. The whole point of this demonstration is that you see I'm running a data engineering stack and I'm running a full stack, so both things in the same VM. I have allocated, I think, less memory, that is 6 GB or something, and in that I think we still have. I mean, you can increase that. So those who are willing to increase the memory, you can see in the Kickstart Linux in the Vagrant file. If you see here, you know that we have a memory option here. You can increase like however you want, and rerun the VM. Okay, so
Okay.
that will help. So it's all in the open source only. Anyone can take anything and try to blend it according to your needs, and you customize and use it. Anyone having questions? You guys can vocally ask anything, even if it is wrong. Also, it's okay, fine. I'm willing to answer that. So you don't need to feel shy about it. The session is over, so I did close on time, and you can ask whatever you want related to the subject. Okay, fine. So if there are no questions, you guys can drop the call if there's no questions.